Hello and welcome to next video. This is something else than the PGBF related build, but in a way this could be related to that as well, because we are taking a look at this Nexus power supply NX 3500. It's 350 watt power supply that is 5 volt heavy and just old enough to have -5 volt. So this would be actually quite ideal power supply for that build, but this isn't mine. I was asked to recap this one, but recapping here isn't really the biggest problem. Sure, this has depots inside. They are not good, but I think this has those better depots, blue ones, or was it also brown ones that didn't leak? Those green ones definitely do leak. But this has the glue that turns into corrosive and conductive, and is very bad for power supply. And what I mean by I think this has, because when I try to see, take a look here, well, it actually looks quite good. There are that bad glue, yes, but there's also another glue that isn't problem. But I myself have this exactly same power supply, and I opened that one so I could see what kind of capacitors I need to order for this one, and we can do comparison, because let's just take a quick look. This is now. We'll take a better look, because mine has serial number that is quite a lot lower than this one, and otherwise the model is the same. And this, by the way, we can take a look at the bottom, are made by FSP group. Here, revision 1 reads on this my power supply, PC below the PCB, under the PCB. But we take look at this later. This isn't very easy to move around, but if maybe this is later revision, I don't know. Maybe it has some improvements. We'll see. But really, these Nexus power supplies, and I'm sure there is probably a matching power supply made under the Watron brand, and perhaps some others as well, but this is manufactured by FSP group. Yeah, I hope I can find some review about this power supply, because I myself bought that one you just saw because of those old good reviews, but I didn't know about depots and conductive glue and things like that. But power supplies made by FSP group, well, those are the things you can expect, both depots and the bad corrosive conductive glue. And that's just how it goes, unfortunately. So biggest problem, I think, isn't about recapping this, it's about getting that dangerous glue out, because I can't leave some glue that turns into conductive or corrosive. It will ruin the power supply eventually. But let's just open this and see how bad it looks or how good it looks, and compare this to. Let's just open this one and see what we're dealing with. I bought a good quality capacitors, of course. I don't think if you are going to order new capacitors, well, sure, those good Japanese, they are expensive. But if you think something is worth recapping. Well, I think you better do it the proper way and just use quality components, because when you order a small amount of capacitors, well, even the bad ones are going to cost more than you would like, so just go with the good quality ones. And I'm sure it's not going to see quite well on the camera, but we do have the contacting glue here in a place where it's the most hardest to get rid of. There's not much, but this area down here, it's full of components and everything is glued together with that awful glue. This white one here, it was actually silicone without any color on that my power supply, but this is white one. But this isn't the problem. It's nicely white. It's this one you can see here perhaps. Well, this yellow one, and it turns from bright yellow to darker yellow and eventually to brown, and that's bad. You don't want it to get brown, because that's the bad things start to happen. But this power supply, I can already see this is in much better condition than my one. But let's get this out of here so we can compare and take a look what we need to do. Oh yes, this also needs to be. This I don't like, when you don't have connector for the fan. And this is especially bad because there's very little space to move this around. You need to unscrew this one, and also this is screwed to the heatsink. This also needs to be removed. Then there's the PCB, of course. I think there's already 5 kinds of different screws, and this will be the 6th different type of screws. You need to remove this one to get access to this screw here. 2006 week 36. I'll just have to take a quick look about the mine. I think this was older. Yes, this is 2004 week 43. This is definitely much later unit. But are there any differences? Well, at least this has the bad glue. And the T-posts, yes, this does have T-posts. And they are brown T-posts. No bulging capacitors. But we'll take a better look. So there wasn't any bulging on my either, but T-posts are T-posts, and I don't trust them and I wouldn't want them on my system. But yeah, they are T-posts and they are bad T-posts. These aren't the green ones that definitely do leak and pulse and whatever. We can already see the thermal sensor is glued to the heatsink with that bad glue. But let's try to get this. Oh yes, I forgot. You need to desolder some of these mains AC wires to be able to remove the PCB. This you can screw. Let's remove that one. But here, those you need to unsolder. So this later revision doesn't use connectors, just like mine older. Well, I still don't know if this is different revision or not, but later build at least. This is easy. Yeah, that this button is the only that you need to desolder, because there are clips of course, but you would have to pull it to this side, and it doesn't do any good because you obviously can't get the whole PCB out of here through this little hole. So it's absolutely necessary to desolder that one, and I don't like desoldering this because there's very high risk that you are going to melt this plastic here, and you can actually see the wire is bent from below, and the bottom wire is just the opposite way, I think. Looks like to be. But while the soldering iron is heating up, let's actually remove this one. Can I rotate this to better position? Or does it even help? If I can get one of those clips to that opening, maybe it helps a bit, maybe not. Just come out there, but something is holding it. I think it's this up. It's on the up here because they just slightly holds it down. There, yes, now it looks much better. Now, oh, the one below here. Yes, it's intact. Oh, doesn't seem to do much. Let's try 370. Not good, not good. It's not that they're not supposed to be this hard to desolder. I can't even melt this. I think this is lead-free solder. This is why it's so hard. It certainly wasn't this hard on the other. Definitely lead-free solder. Maybe I should add some solder then and see if it helps. Looks better. Let's try this again. Definitely better, but yes, it's free, but I need to cut that cable tie. I don't want to use any more heat than absolutely necessary, because these are going to go bad with too much heat. The other one, much harder. That's certainly one difference. The older one didn't have lead-free solder here. How can I get the bottom one? Because I can't even properly see there. It's not going to be nice to get this back there, but well, we'll worry about that later. Now at least it should be free, but that doesn't mean it would be easy to get it out of here. Let's try not to damage these wires. No, that's better. All right. I wonder if I have some connectors. Maybe it would be best if I simply cut this fan from here and place some connector. I'll just do that. I'm sure I'll find something, and if not, well, there's more than extra length here. But I think connector would be very nice here, so this fan can be easily replaced someday if necessary. I want to get this free, but for now let's move this away from here. And also we're not going to need this one. It looks quite nice. So let's put this away and concentrate on this one. And also let's remove this plastic. Now this also says revision 1. Let's take a look, better look soon. This is the bad glue, this yellow one, and it's all around this one. Let's store this one as well. I need that one. And yeah, FSP group revision 1. And we can actually let's compare the two. I desoldered one of these so I could actually see what it was. But the my is, well, it has the glue is, there's glue down there, and it's very bad looking. This one looks like a burnt. It's very crusty, and this is how it goes, and eventually but actually when it's crusty it's easier to remove. But other than that, there's really no difference, and at least not that I can notice. And if they are both revision 1, well, there really shouldn't be. But yeah, both of these has brown depots, and unfortunately this that I'm recapping here, well, it has more of this black bad glue. It's not in that bad condition yet. It's actually quite bright at the moment, except there, but still it's not bad. I'm sure it's not conductive at the moment, but there's more glue here, and there's quite a lot here under these big ones, and we are actually going to replace this one as well. Usually it's not necessary, but these happen to be depots, and I'm supposed to make this last a long time, so just to be safe, we're going to replace those one as well. And this my power supply, maybe it's just coincidence. Yeah, this, I don't think these are bulging. These are definitely more smooth from the top, but I think there's just air below them, so they are just like this. So I don't think there's anything wrong with these. But we can forget now this my power supply, because there's really no difference, except the glue has gotten in worse condition. It maybe how this is stored, maybe this is older, yes, less than 2 years. Maybe that has something to do with it. Maybe it's used more, who knows. But especially down here where you can unfortunately see, I'm trying to move this very close if I can. Well, the glue there is quite bad, and definitely I wouldn't use this in this condition. So let's put this away, but we can use that as reference if something if I happen to make some mistake or something. This, yes, the glue, it's getting more darker yellow there under there, but it's still not brown. So I think this would be safe to use. It does, although these capacitors are not bulging or anything, but that doesn't mean they're good. But I think it would be safe to turn this on. Of course, the quality, I don't know how much ripple this would produce, but yeah, I think it would be safe to turn this on, at least. But now, the bad glue must come off. And how to do that? Well, it's quite obvious. Here, it's in worst condition, probably because of heat. So it absolutely needs to be removed from here. And all the capacitors, it's on top of the capacitors and everything. And I need to remove the capacitors as well. And I really can't do anything because they are also tied together. So I'm going to remove these wires. It's something I wouldn't want to do, but I think it's just necessary here. And also these capacitors, well, these big ones, they are 3300 microfarads, 10 volt. And there's some others as well, but we'll take better look later. But getting these are 10 millimeters in diameter, and this was the really problem because it was really hard to find capacitors to replace them with. At least Japanese capacitors, because they tend to be 12 millimeter in diameter, or those with 10 millimeter, well, they were usually 6 volt capacitors, but getting 10 volt, 33 microfarad or more, of course it's bigger is even harder to find. Well, there really was just only one option, but at least we have at least one, because you simply can't fit anything 12 millimeter in diameter here, because you simply need to use, even this doesn't seem to even fit there quite nicely. So yeah, you absolutely need to pay attention that you don't get physically too big capacitors here. Two of them must be, or at least one of them for the 3 volt rail, and for that you can use 6 volt capacitor. And actually I'm going to use 6 volt capacitor here, because we are going to just check what are connected to the 3 volt rail and use multimeter for that, and use 6 volt capacitors there. So, but at least one or probably two are going to be for the 5 volt rail, and you need to use 10 volt capacitors for that. But why 10 if it's 5 volt rail? Well, because some ATX specification, this is 5 volt rail is supposed to withstand 7 volts. And of course, components on your motherboard, on whatever you're connecting here, well, they are not going to stand for 7 volts. So using 6 volt capacitors here, well, if this would have been my power supply, I could have done that, and would have done that, because, well, if voltage for some reason is starting to approach 7 volts, I think I much more prefer that power supply itself is going to let the smoke out, and not my motherboard or something else. But of course, if 6 volt capacitor is going to fail when voltage goes over 6 volt, well, who knows what it's outputting to the motherboard, so perhaps that wouldn't even save the motherboard. But yeah, the reason we are going to need 10 volt caps on the 5-volt rail. It's because the ATX specification. The power supply itself is supposed to withstand 7 volts on 5-volt rail, and that's just how it is. Getting these wires out well. It's just work, and getting them out might not be that bad one, but getting them back in, well, that's certainly going to be hard. But I think these are marked quite well on the PCB, at least the ground one. It's easily shows where the ground wires go, and I'm sure that holds true for every else as well. And if not, I have the other power supply where I can double check. I wonder, should I just desolder this one to avoid any? Maybe I should start with that one, because I may drop this one and then I damage something. And let's try to record where it actually, how it goes. Let's see if I even can get it out of there because of that glue. Yeah, I can already tell recapping won't be easy because of the lead-free solder. I need more heat. Yeah, 380, that's better. At least a bit. It's like it doesn't do anything much, but all I need to peel off that. Like so. The white wire. It's actually this same blob where the red wire is. I think this one on the corner here, this is the white one. Or actually is it? Well, it's something there, that's so. No, it seems to be from there. Maybe they are all coming out. Yeah, you can easily see where I removed them. But I'm going to, of course, need to get that solder off. But for now, this one won't cause many problems here. But yeah, you see those two wires. I think this is going to take a while. That was a lost cause. It simply it's not going to work. You need, I don't know what kind of blowtorch you would need to use here. Soldering iron certainly, at least what I have, doesn't really work here. I was able to desolder one of these. And let's take a close look. I don't know how well it sees, but actually there's some kind of connector at the end with those sort of clips or whatever that is going to hold it in place. So you just can't simply heat the solder from the bottom and pull this away. It's not going to come. So really, I can't desolder this. It's going to take forever. I might make some damage. And I bent this as good as I could to get access to the capacitors. And it looks like I'm going to need to desolder the capacitors, and then, well, actually I think I need to try to get most of the glue from the capacitors and then desolder the capacitors and then clean rest of the glue. I think that's really the way to do it. So let's first free capacitor. You need to be careful of any coils. Since I'm going to need to remove the glue, I can simply remove capacitor and then replace it with new one, because I need some space around the glue so I can remove it. And yeah, I really hate this glue. This is going to be real hard and take a long time. If I could at least get two of those big ones, because They're mostly on the way, and perhaps that one as well. Rest, well, perhaps they are so small that I can get the glue better. This around the coil, or rather maybe it's this big resistor here. It's hidden the glue, so it's brittle here, definitely. Exact the same thing was on that the power supply on the Asus P3PF build. Well, it looked almost like burnt, that glue there. This is in much better condition, but when it is really brown, it's crusty and much easier to remove. Actually, what I did with one power supply, I never finished it. It was 400 watt Nexus, by the way. I tested a method to remove this glue. I tried it with turpentine. I bought it so that the PCB was barely covered with turpentine, and then left it, and of course the glue, and then left it overnight and see if the turpentine has softened the glue so it would be easier to remove. And well, whatever effect it had, it was so minimal that really that wasn't the way to do it. Because the turpentine, well, it's going to cause damage with plastic parts and whatever, so possibly the varnish over the coils and things like that, so don't do that. You really need to mechanically remove the glue. There is no other way. But for now, I just want to get those biggest capacitors, this and this free. Then I should be able to remove the glue. But it's not going to be easy to desolder these ones. But at least they should now come off. Let me desolder this off camera and then we'll return. This 3 watt back, quite a lot. It's really hard to desolder this one. And this wire there, this is ground. Well, that doesn't help much. Lots and lots of lead-free solder on top of this, and capacitors there. But at least these 3, no surprises here, and doesn't appear to be any leaking here. These are indeed 3300 10 volt, and this is 1000 microfarad 10 volt. This Jamicom branded green one, but it was from the center, and those were the dull ones, of course. But at least now I can get all the glue here, and I also need to remember scrape the glue off here. Although yes, this is already on the ground, so it doesn't really matter. But still, better safe than sorry. If it turns conductive, it doesn't matter here. But if it turns corrosive, well, it might corrode this trace there, and that's of course bad thing. This coil appears to be good. Just a little bit of that glue on top. We'll get that one. Yes, now there it goes. Let's try to get the glue here from these wires. This would have been of course easier if I would have been able to remove all these wires, but well, that was too optimistic to think, but it's not very stuck on these wires, so just scrape them and they come free. Of course I need to at least blow some air here to get all these leftovers there. I don't know if there's anything better than this. This is actually quite good for this job. These coils I'm quite a bit afraid because of the varnish. Need to be really careful about that so I don't damage those. Let's try Could this be here? Put here? I don't know. But I'll continue removing the glue and we'll come back and see later. I've now removed most of the glue, but unfortunately, let's see if we can look it with microscope, because there's, well, it's not too big of a problem, but here I managed to broke resistor, it goes there, and some of this coating came off, so I think this is better to be replaced. There was a large blob of glue here on top of this, and potentially it could have shorted quite a lot of components, and this was completely under the glue, so I couldn't even see this resistor. And here let's take where the big capacitors, where the 3300 microfarad capacitors were. Well, I think this is as good as I can get the glue. This is capacitor, this of course will go. Perhaps I can get a bit more of this after I remove this one. But yeah, I think it doesn't see properly. I think this heatsink damaged a bit here, but perhaps I can replace it. It's probably there, so it doesn't short these two together. But yeah. But other than that, this took quite a lot of time. And I think I'm ready to start recapping this. These big ones, I haven't done really much of anything here at the moment, because I think I'll leave it like this for now, and after this side works, well, although actually I don't know yet, but I think I'm going to start recapping here these first, so I can fix that resistor and whatever. I think I'm going to remove these two and then replace that resistor. Let's see. I think this is one of those. Was it? Yes. And the other one is, let's see, it must be this one. Let's start here. $100 microfarad, 25 volts, and the other one, I think maybe I should remove this 4 as well, so it's no, but then there's that one. I need to write some values so I can remember where I took and what. So let's see, it was C26. Yes, there's two components under one blob of solder. This alone doesn't seem to do anything. That should be 3. This is 100 micro 35 volts, but what exactly is it? Is it C37? Yeah, it definitely looks there's two. One big hole and shed hole with one of those legs. It's C37. And then the last one from here. Then I can fix that resistor and replace new capacitors. 10 micros, yes, 10 micros, 50 volts. And it was let's see, 24. Can I get some more glue? At least a little bit. Yeah, it helps a bit. Now that the capacitors are removed, I can better scrape off. Yeah, I think that's good. That's good now. But what about this small board here? I could remove it to easily recap it, but perhaps the bottommost. It's hard to place new capacitor there, but other than that, it's possible to recap this without removing it. Perhaps I should do that. But first, that resistor. And it should be, no, yes, it's free. I hope we can measure it, but if not, I do have the other power supply. Alright, let's try to measure it. It's hard to read it because part of the coating's lost, but 10 ohms. Is it really? Yes, it is 10 ohms. Let's try to find a replacement. Just a little bit bad news. I don't have 10 ohm resistor. I don't know why. Have I used them? Are they lost? But I don't have. So I'm going to connect these in parallel. And that should give about 10 ohms. And fortunately, it's here in the area where there's actually some space to use two resistors in parallel, so I don't think this isn't such a big deal. Another possibility would have been to use SMD resistor, but this here, well, sure, if you would have scraped off this, yes, you could have used SMD resistor there, but let's just do things this way. And I'm just thinking maybe I should connect them in parallel right now. Maybe something like that. I know you can't see much at the moment, but there's really not that much to see. That's quite nice, I think. The other end. Well, it's not going to be too pretty, but it's not gonna stay visible anyway, so hot. Alright, let's measure the resistance, just in case. Although I don't think there's really any surprises here. Very well, very good, 9.94, and it was 9.8. The broken one. If I can get it there somehow. Alright. I think that's good. But now the capacitors. I think I'm not going to replace these just yet. Rather these from the small PCB first, because I think I can get them replaced without removing this. Especially now that there's no capacitors here. It's just that well, those two on the bottom there, they might be a bit hard, but these are of course easy. This shouldn't be too much problem, especially not that one. But then there's two small ones there. Another is bent. It might be quite hard to, because I could otherwise remove from here, but then I would have desoldered those SMD capacitors there, or I could remove them from here, but everything's been a bit hard. It's just this resistor. Of course I could, if necessary, remove this resistor. Then I can certainly access those. So perhaps that's better. I'll try without removing the small PCB, and I remove that big resistor if necessary. I don't think there will be much to see. These are simply small capacitors. This is perhaps the biggest, 47 microfarads, and then there's 1 microfarad, but really nothing special. But I need the fan connector also. I need to find something. But this small PCB, that I can recap off camera. Alright, the small PCB is now recapped. And there was one surprise. Let me show you. One of those capacitors. Perhaps this one. Yes, it was 16 microfarad, 16 volt. And that's not usual capacity. And I didn't of course have 16 microfarad, but I would have had 22. But instead of using 22, I connected 10 microfarad and 4.7 microfarad in parallel to get about 15 microfarads. And this is on this side of the PCB is the 4.7 microfarad capacitor. On the other side, where it was supposed to be, is the 10 microfarad. Well, there's somewhere. Some couple of these capacitors, or rather three, are physically a bit bigger than the originals, but that doesn't of course matter because they fit there. This was, by the way, for the fan, to smooth out the voltage for the fan. And now there's connector for the fan, the hot glue. Hot glue keeps it in place at least. Well, it's not, you don't have to use that very often, really. Hopefully never, but there's connector there, and I think it's better than the just soldering the wires. Of course, I'm going to need connector to the fan as well, but I hope I have one. If not, I'll have to just take from some used fan. But this small PCB should now be good to go. Of course, there's lot more capacitors left, but this is a start at least. It was a bit tricky to get those, rather those three and perhaps this fourth one as well, but this was the easiest. But yeah, these were quite hard. I had to bend this a little bit, not much, but still it was possible. So perhaps this was easier than to remove this small PCB. And now I have to hope this capacitor added to the back will fit. I think it's tight fit, but I think it's going to fit, so we'll see that eventually. next, these capacitors I removed from here. Now I can replace those. And there's capacitors under this one there as well. I think those are going to be the next one to be removed, so I don't forget them. But I better show the capacitors here now because they're not going to be on the way when I remove this one from this side. Before soldering back those capacitors from this area, I think I'm going to remove the last big one. Last of those smoothing capacitors, and then I'm going to check what were the 5 volt and what was from 3 volt rail. So I don't at least forget to do that. So none of these capacitors have leaked. That's of course good. So now let's see. All right, ground is easy. This should be ground, yes. But this, how can you see? Well, here we have red wires coming out on this, and orange wires are there. So, and yellow comes from here, and we could of course measure from here as well. Yellow would be the 12 volt, and it's here. Red would be 5 volt, it's here. And orange, well, we need to take SATA connector for that one, is here, 3 volts. So this was from 5 volt rail. I think I'll just wrote 5 somewhere there. And this I'm sure it was from 12 volt. Yes, that's ground, so this must be, yes, you can already see 12. That was of course easy because it had 16 volt capacitor there. Next, these 3 here. So let's take that from there. This is of course ground, I can already see it, but they can both be ground. No, it's just that it's 7 ohms, so it beeps. But this definitely 0 ohms, so yes. But 15 ohms about. Yes, it looks like to be 5 volt. Let's write 5 from 5 to there. So these 2 must be 3 volt then. And let's see. This is of course ground. And this should be, oh, this is ground, of course. Yes. So this here. Well, I can already see it's where all those 3-volt wires go, so of course it's there. And this other one, well, yes, they are 3-volt from 3-volt rail here, these two. Hard to write, but I don't know if it's going to see. Can you see it or not? But let's try. So now I know where to put those 6-volt capacitors and where to put those 10-volt capacitors. Are there something else? Because there was this 1000 microfarad. Because another of these 5-volt rail smoothing capacitors, well, it was 1000 microfarad. It was this from there. And I wonder why, because definitely 2 of these are on the 3-volt rail. So why is there more smoothing capacity for 3-volt when this 5-volt should be the heaviest rail? And of course this 16-volt 2200 microfarad was on the 12-volt rail, but this we are going to actually replace with 3300 microfarad, but we'll take a look at those later. But this, why is there 1000 microfarad instead of 33? I don't know, but I think, let's see, was it actually heaviest rail? Yes. Well, not really, because on 3 volts you have 25 amps and on 5 volts you have 30 amps and almost the same. But still, I would have expected this to be reversed. So 5-volt rail would have those 2 of those 3300s, but not here, it seems. So we are forgetting about the 1000 microfarad. We will place 3300 to both of these rails. And 12-volt rail is also going to have 3300, but of course there's only one of those. And let's take a look at this. What was the 12-volt rail? 18 amps. And of course ATX specification allows, was it 120 millivolts ripple for the 12-volt rail, and was it 50 or 40 millivolts to 3 and 5-volt rail. So it's completely expected that 12-volt rail has less smoothing, especially since less smoothing capacity, especially since it was only 18 amps. I'm going to place those capacitors there, and then after that I'm going to desolder these. But now let's add new capacitors. What would be hardest is that smoothing capacitor for 12-volt rail. Actually no, the one next to it. I'm going to at first add this here in the middle and then go to this direction, so it's easy to put them in place. But that was it even populated? C24, of course it must have been 10 micros there, small one. Let's start with that one. Panasonic is going to that C24, and it's actually, I can't place it without some tool. This is exactly the reason I want to place this hardest first. What about my power supply? The Nexus, that's exactly like this. I don't actually know. Because I could of course goes to this very same thing to that one here, and I suppose it would be power supply I could use for testing and keep it as a bench power supply. Recap then. But I haven't decided yet. Some of these actually legs are left quite tall, so they might even cause a short if I'm not. But I'll take care of. I'll look at that at the end to inspect that everything's okay. So now the smoothing capacitor was a 12-volt rail, and let's see if I can find it. Well, I need to recheck what these were, but these are actually quite tall, taller than anything. Let's compare this original, but this doesn't matter. It's going to fit there, and it's not surprised that this is bigger. This is 16 volt and this is 10 volt, but this were on the 12 volt rail. But it is expected that you have higher voltage, then the physical size is going to be larger. And because I need to use 10 mm in diameter here, because largers don't fit, so this simply must be tall. Here is our new 12 volt rail smoothing capacitor. The original was 2200 and this is 3300 microfarads. Actually, I need to. This is the good glue. It won't cause any problems, except I need to remove it so that there's going to be space where to put this capacitor. Well, this isn't elastic at least anymore. It's actually quite brittle. This better glue. It would have been quite easy to remove if that bad glue would have been this brittle, but no, of course not. And this temperature sensor I'm going to connect it last. So it's floating there at the moment. And here. Tight fit, that's for sure. But it was cramped there, the original capacitor as well, so I guess this is to be expected. C24 is now done, C25 is done, it was this big one. And what would be next? I think it's the one with, was it C37 that says hole with one of those. That's 100 micro here. Actually, these are 85 Celsius now, then I need to use this one. These are perhaps a bit big, but let's hope it fits there. You're supposed to use 105 Celsius rated capacitors on power supplies. Yes, it went there, but yeah. Well, this is, I can't get it to fit any better, but it's going to stay there at least. Now, rest should be easy, and there shouldn't be any surprises there. So, but I'll solder these capacitors here. There's nothing special about them. I solder them off camera and then we can move on. Actually, something we could check is that 470 microfarad capacitor that I already replaced. This one here. Well, we could actually use multimeter to figure out where it's connected, because it's probably this 5 volt standby voltage, and it was this one. Yes, it is 0.4 ohm, so it's directly there. So it is the standby voltage smoothing capacitor. But I already replaced it, and that doesn't matter because here we have a problem. You can't fit anything larger there. It must be 8 millimeters at most. Of course there are. Let's see here. These good Panasonics are 8 millimeter in diameter, and they aren't even tall, but they are 6.3 volt capacitors. And if you want to keep this within ATX specification, this power supply need to withstand 7 volts on the 5 volt rails, and well, that obviously can't do it. So you would have to use bigger. And here we have an issue. These 16 volt caps, well, they are 10 millimeter in diameter, and perhaps this would actually, yes, it would. This isn't too tall. This is 16 volt. This isn't tall, but I think this is 12 millimeter in diameter. So none of these width. So I really don't have anything to replace it with if I want something bigger there. So I don't really have anything to replace this standby 5 volt smoothing capacitor. But personally, I avoid to keep just about anything in standby. So I really like hard power much better. It's much safer and doesn't waste energy. And but of course, if you don't keep your stuff in standby, if they have those batteries inside, well, you are going to need to replace batteries sooner, but that's usually not really an issue. So we'll just keep 470 microfarad smoothing capacitor for the standby 5 volt voltage, because well, nothing else fits there. Of course I could bend the legs and place it somewhere here, but it would look quite bad and definitely not very professional, and so let's not do that. It's just standby voltage, and we are using 470 microfarad that has lasted in this power supply for almost 20 years now, so the new one is definitely better quality than the old one. And also I glued this coil in place because it was already glued originally, and this little bit, so they can't move there now, and because there's that fixed resistor, two of them in parallel, so it doesn't cause any shorts if something moves and so on. So probably not necessary, but better safe than sorry. I think, before I forgot, there are 3 capacitors below this heatsink hidden. It's going to be very hard, especially the farthest one. It's quite in the middle, actually, somewhere just down there, to get something there. It's easier to get this out than putting new one in. These I can manage, these two. But luckily there's only 3 capacitors, small ones. And does it see better on the other side? This one is hard to replace. But after that, these should be easy. And at last we'll take a look at these. But now let's get those 3 below the heatsink. Alright, the other leg is there. But is it enough? I could grip it from the other side. No. Another try. Almost there. Yes, now it went in. And looks like I need to bend another leg so it doesn't fall out. But it's there alright. Yes, it doesn't touch the heatsink. So it's good now. That was a bit tricky, but it's there. And it's there quite nicely actually. So let's concentrate on these small ones here. There's 1, 2, 3. So yeah, 3 capacitors to remove and something well out at least. I need to keep cleaning this desoldering gun quite a lot. I don't know. Yeah, it's already. I don't know if it's this low melt solder paste itself or the fact that it's lead free, but it gets stuck quite a lot more than with just old leaded solder. 100 microfarad, 25 volts. Yeah, this is covered with glue. 100 microfarad, 25 volt. Wasn't this 100 microfarad as well? 25 volt. So indeed, they are the same but different brand. Tipo and Chamigon. There's not much glue left. I think I got most of it already. I need to be careful with these coils. I don't want to scrape them any more than absolutely necessary. These are 81Cs and these are a bit bigger, but I think these bigger ones will fit there. This isn't going to fit nicely. Well, actually these are 25 volt as well. I have 3 kinds of these. These were definitely the low ESR, but I think these are Panasonic as well. They are bigger, but I think we're going to use these. So what I'm going to do is remove that plastic to get even more space so it doesn't have these corners, and solder it like this. Yes, definitely this is the perfect size. Maybe a bit tricky to solder these because they fall out so easy, but we'll just have to manage something. Right, and the other. Let's place a bit more solder to that one as well. Right, the size now won't at least cause any issues. I think it will be just nice there. 1 old capacitor left. Well, that's easy. 10 micro 50 volts. That shouldn't be hard. This is Panasonic, but this is 25 volts, but there's absolutely certainly nothing even close to 50 volts there, so this will be just fine. Now all the small ones are now replaced. So let's put those big smoothing caps next. And we already measured what was 5 volt and what was something 3 volt rail, and one of them is there, and here there was 1000 microfarad, but that we're going to replace with bigger one. So it was really hard to find 10 volt 3300 Japanese capacitors with diameter of 10 millimeters. 12, yes, that would have been easy, but not with 10 millimeter diameter. So there was really only 2 options. I could solder this with 16 volts, that was tall, that I used on a 12 volt rail. I certainly could have used it on the 5 volt rail as well, but this is of course more expensive. So, and the other option, well, there wasn't simply other, it was just this Rubicon 10 volt 3300 microfarad. So this is pretty much the same kind that originally was there, except this isn't quite even as tall, but that doesn't matter. And I'm going to need 2 of those for the 5 volt rail, and the other was 1000 microfarad, but I'm using 2 of these. And for the 3 volt rail, well, here is, it was a lot easier. There was much more options for these 6.3 volt capacitors. Yeah, these are Panasonics. So this was 5 and 3 here, but that's actually quite good because these 6 volt capacitors for the 3 volt rail, well, they are closer to this edge here, so these are the hardest spots, and we are using the less tall ones there. Very good. And just the final capacitor. Well, not quite final because we have this one as well, but now the harder side. Lots of flux. Oh, much more heat needed. Now it's starting to melt there, but not as nice I would have liked. I need more heat. 390 at the moment. Oh, now that starts to look really nice. This doesn't look good, but I can't help it. It's the coil. Well, perhaps. Oh. No, it is what it is, and we just have to live with it. It was like that originally also. But now this wire, I have actually 3 places where I can push it through. It's definitely now properly soldered. Absolutely it is. Now I can bring down the heat again. These new ones, they are Nippon Chemicon. So these 2 are Japanese capacitors, like everything else I put here. Well, these are taller, 5 centimeters or 50 millimeters, while these original ones are 45 millimeters tall. But this heatsinks, this is perhaps bends a bit, but you can see the heatsink is already taller. So 50 millimeter is going to fit here. And these were very hard to find because, again, there were lot more options if you go one side up higher on diameter. But these absolutely need to be 22 millimeters because they are touching each other, so nothing else won't fit. And really, these were the only ones that I was able to order, and these are actually better. Ones here, it's not going to see very well. These depots, they are 820 microfarad. These are 1000. So these are good for higher wattage PSUs. Who knows, maybe 500 or 50 at least. These are going to be better than needed, but of course that's always good thing. And probably these are already good. But we want Japanese capacitors here, so These are going to be replaced. But they are glued. Perhaps even from the bottom, at least on the sides. They are glued together. There's lots of things there, and it's going to be hard first to even get this out. And also something I should have mentioned from the very beginning, that if you're messing with power supply, these are the ones that are going to give you a shock if they are charged. And they are charged if you just tested this and it was in use even for a second or so, and they are going to give you nasty shock. These are 33 ohm 3 watt capacitors, so basically you could have simply bent these, perhaps hold them with something nicer, and then discharge them like this for a few seconds, and you could of course use multimeter to measure that they are actually discharged. Both of these certainly. And after that, this should be safe to operate. But I didn't do that because this has already waited a couple of weeks for those capacitors, so this was definitely safe to touch. Now I need to get those capacitors free, and all that glue that remains, I need to get that up as well. But yeah, this is free from solder, yes. Actually, this was quite easy. Well, I got them out. There's glue everywhere, but this glue doesn't really matter, because there's nothing it can corrode, no metal. There's nothing it can short, except there. There's some resistor or whatever. Yes. This and this diode bridge. Those are the only thing it can short. And perhaps leg of these two. But so I need to clean a little bit of that glue, at least enough that it's never going to cause any short, even if it turns conductive. Because I can't get it 100% out, so just get enough so it doesn't cause any harm. I wouldn't want to desolder anything if not really necessary. Yeah, I think I can get that glue there, yes, very good. I don't think there will be any issues, they'll just fit there quite nicely, at least they're supposed to. Yeah, looks like they are the same height as the heatsink, so definitely no issues there. Alright, they are there now. New big ones. And this transformer, the white wire, it was there, this side, and black was on that side, but I need to clean those holes first. That's not going to be that easy, because it is under that blob. Maybe we'll just have to remove that blob completely. Now I think the hole is free. 2 holes, but they go to the same place, so it doesn't really matter. This is ready for final inspection. No, actually this temperature sensor, it still needs to go there. Perhaps I'm making it better as well. Where do I have thermal paste? I could put that a little bit there. I know it already has this heat shrink on top of it, so I'm sure that insulates already something, but let's make this as good as possible. Now I'm going to glue that there, so with hot glue, so it stays there, and I'll do the final inspection of camera, and then we can put it back and see if it works. Let's prepare this fan. because we need to add the connector, and unfortunately I couldn't find any here that isn't in use already, so we'll just have to borrow. This is the GeForce 4 MX that had broken memory, so I guess I could use this as a spare part. If I'm going to use this or fix this later, yes, this is right type of connector. Well, I either get more of these connectors or perhaps do passive cooling for this one, but for now let's repurpose this. Connector. Let's try something like that. Is it going to end up in failure? What happens? Suppose it is okay, but maybe flux helps a bit. Let's make it a bit better. All right. Yeah, this should hold. But we're not done yet with the cooling fan. Let's remove it because I think it's better to lubricate it as well. Everything is actually quite clean, but I'll clean this off camera quickly. You can see there's air bubbles below this tape, and that's good indication that the oil has leaked from the fan, and it's under this tape. So we need to get it off there. Perhaps heating helps. Let's see. I'm blowing air. It's 100 degrees. Maybe it will help. It is actually quite stuck. Yes, you can see the oil. Oil definitely has leaked. And this, well, perhaps I could place it on the other side just to remind what kind of cooling fan this is, or perhaps I'll just put it over something else there. Let's store it. Let's just try to preserve it anyways. This is rubber, and of course it needs to be cleaned as everything else. But it doesn't look completely dry, so, and this didn't sound like it would have dried. Actually, this is very, it doesn't keep any noise at all. So it's in good condition, even though it has minor leaking, but we'll fix that one. I need to get all the oil out of this so I can glue a new tape here. And of course I want any old, perhaps dried oil removed from there also. I'm probably going to have to clean this anyways after applying oil, because I probably drop it somewhere, but this is some universal all-purpose oil. Oh, looks like 3 drops went in. I was hoping just 1, but looks like that wasn't too much at all. Actually, it looks like it was just the right amount. Just a little bit IPA perhaps. I don't want to drop it there with the oil. Let's place the cap on. Now I'm cleaning it one last time to make sure there isn't oil, because I'm going to put tape here. This is aluminum tape, but it doesn't really have to be. Clean this one as well. If I want to preserve this, I could put it back with double-sided tape, some thin double-sided tape, and let's try to get this somewhat round. It doesn't really have to be, but especially if it's under the other. Like that, and all right, I found the tape, so we can finish the cooling fan. I simply cut a piece and try to place this old sticker so that there won't be any air bubbles. Now, well, I didn't manage to place it completely on the center, but that doesn't really matter. I managed to hide the aluminum tape under it. So not bad. This is Nexus branded power supply, but it doesn't use Nexus fans. Actually, we should have perhaps compared before I mounted this back, but let's try to see anyways. I have those Nexus same color as this one. Maybe the values are the same. Let's see. Yes, 0.30 amps, both of them. D12 SL-12. Yes, even the model number is exactly the same. It just doesn't say Nexus here, rather the real manufacturer, Loon Electronics. But this says Nexus, and these are of course probably case once you buy separately. So yeah, but this is absolutely the same cooling fan, absolutely. And of course this has the sensor that's missing from this one. And I think these were supposed to be quiet fans, good fans. They had good reviews, those Nexus branded back in the day, so I don't think there's any point to replace this unless it sounds bad. And this certainly didn't. Even without lubricating, it sounded, there was absolutely no sound from the bearings, and now it's going to last longer. What we should do now is put everything together and test this. Except there's the issue with this power button. Well, it works, no problem with that. But because I need to solder it, well, I could use connectors, but unfortunately I only had one of these sized. I just checked. And to be able to use the connectors, I need to get all the solder away from these, and definitely there's probably little under there, but here perhaps. Well, it's going to be really hard, and since this is lead-free solder, I am most certain that I am going to melt the plastics on this connector if I'm going to clean this completely. So yeah, even if I would have those connectors, 2 of them, this would have been a little risky. So I'm just going to solder those wires back together, but I don't want to solder them. Actually, I should scrape this glue off as well. There's not much. And it should come out quite easy. But actually not as easy as I thought it would be. I could, of course, if it won't come out, just place some tape over. I think it's like this. Definitely yes. This is a tight fit because I need to get this under there somewhere, under this wire, and this is loose, this transformer, and heavy and everything. And all right, that looks quite nice. Perhaps I'll place some heat shrink there so we can properly cover them later. I suppose I'm feeling confident enough that this is going to work. All right. And also let's dip them to flux. And that's definitely going to need more solder, but I think it's good enough for testing. Now we should have our standby voltage. Let's see, turn the power. Nothing happened, very good. Purple and black. Yes, we do have standby 5 volts. Actually, now we can use this one. And let's connect this, and we should be able to power on the hard drive. Hard power and soft power. And it spins. And it should stop when I breathe this. You probably can't hear anything, but yes, it stops. But we are going to measure voltages. 12 volt. Very good, very good. And 5 volt. 5.1, but we have very little load at the moment, so this is expected. Can we actually get, we do have SATA connectors here somewhere. Check the 3 volts as well. It would be the orange. It's a lot harder to measure from this SATA. Actually, I'm going to take ground for somewhere else. Does it stay there? Of course it won't. And try to get reading from the pin on most edge of this connector. Now I lost ground, it seems. 3.37, yes, and this is without load, so yeah. I need that more solder here, and this. Perhaps this is something I should do now. Of course, now this is dangerous. These big ones are charged, so they are going to give you shock if you do something you're not supposed to do, but we'll be careful. Yeah, they're not going anywhere. So now let's put that heatsink on top of this to make it safer and nicer. Perhaps I'll clean this area a bit and surroundings a bit, and then we'll put this back together and do the final testing. Here are all the screws. Let's start with that transformer. Or rather, no, let's of course start with the PCB, because one of those screws is under the transformer, so that's better. There's barely enough space for the capacitor. We have that on this side of the board. This bends enough that this won't be a problem, but this here. But I think it will fit. So no, there shouldn't be any problems with that one. And now the transformer, let's take those. I think it's... Yep, that's good now. And I think these wires have to be next. Maybe I should just use some cable tie here. Yeah, I think that's good. And let's put this one next. All right. Yeah, that should hold those wires so they don't come up and go to the cooling fan. Oh yes, it's here. We have one more heatsink. It needs to be screwed, and it's this one. Now that's better. Now we have 5 screws left, and let's try to place this somehow nicely. 2 or 3 times around this one here, and perhaps that's how I should put this one. No, not twice, just once. And let's connect. It went easily, but is there a risk that this gets somewhere where it's not supposed to go? Maybe from the other side. Is it better then? Yeah, I think it is. Shouldn't be any issues with that one. Now, yes, it fits. It fits, and definitely the fan doesn't touch those big capacitors, so 50 millimeters, this was the maximum. There's perhaps a couple of millimeters space, and there of course needs to be. So yeah, I think this is going to be real nice. But yeah, it's now ready for final testing, and I need to find something to test it with. Alright, I made this wild looking thing, and this is nothing more that it simply adds 10 microfarads electrolytic capacitor between ground and voltage. 12 voltage here and 5 voltage on this side, and in parallel to this electrolytic there's a 100 nanofarad ceramic capacitor, and this is how Intel, it's in the Intel specification. Well, this is how you should measure ripple. And on this other side, this is ground, and this is plus 12, and this is plus 5 volt. And you're not supposed to use anything long. This is actually too long to measure ripple, this ground lead. So instead, let's remove that one, and we remove this one as well. You need to keep distance minimal between ground and the voltages. So how this is supposed to work is you place this ground to this ground pin, and this is how you measure plus 12 volt, and the other side, well, this is how you measure plus 5 volt. I forgot to test minus voltages, that they are what they're supposed to be. So let's just do that one. I have now 5 hard drives installed. They doesn't appear all on the camera, I know, but they are here. And ATX to AT adapter. So I need to connect these so I can start this. And I just hold them with these. And they are now outside picture, but that doesn't really matter. They are there. And I'm also going to do last attempt with this oscilloscope to measure ripple, but I simply think this isn't good enough for that. But let's start with the minus voltages. Everything should now start. No, yet another power switch. No, that's better. I'm measuring from the AT connectors. There's minus 5 volt. This should be 5 volt, yes, it is. This perhaps a bit high, but not too high. And of course, I'm nowhere near at maximum load, so it's probably closer to 5 volts. And was it 30 amps on the 5 volt rail, and when it approaches that one, so nothing to worry. But yes, we have minus 12. This should be plus 12, yes. And again 5 volt. But yeah, they are all voltages are present, and nothing wrong with those. I checked, there is no firmware upgrade for this one, because apparently the microcontroller is locked, so you can't update the software on this one. But there is open source alternative software, firmware for this. But since this is locked for programming, well, you just have to replace the whole microcontroller to replace the software. And so I can't do that at the moment. I would have to order microcontroller. But I'm not sure is this hardware issue or software issue. It could be either. But you would think that something like ripple, it's definitely something you should be able to measure with oscilloscope. And also apparently the 1x setting, well, it's only 5 MHz on this oscilloscope, and if you use the 10x then it's 100 MHz. But on the 10x mode, well, I can measure such low voltages. such as ripple. So not that it doesn't really matter here at all. This issue is something completely different. But AC definitely I need to use, and 50 millivolts per division and 500 millisecond was where this actually could measure, and I don't actually know what it's measuring at the moment. It's not connected. There's no ground at the moment, but actually let's take 200 milliseconds. Can I do the same thing? But as you can see, it's like this software gets very, very slow. It takes several seconds before updating it, and so this could be entirely software issue. Does it help if I use 100 millivolts per division? Does it update any faster? No, it does not. What if I use the next settings here, but not on the probe? Well, it just multiplies those voltages by 10, but it doesn't really help in any way. So this just gets very, very slow unless I use the 500 millisecond setting. Then it updates correctly. What if I use 100 milliseconds? It measures, but it's just as slow. 50 milliseconds. With this I could at least get something, and it should now actually measure something, but for some reason last time it didn't. But can I even trust these results at the moment? Because certainly the scope isn't functioning the way it should. It shows around 60 millivolts peak to peak, but I can't really trust this, and that would be actually too much, this 60 millivolts. So I don't think something is wrong here. Now it supposedly works, but why didn't it work last time? It's just that I can't really trust anything about this. Let's try the 12 volt side of things. if I can trust that one, it would be good. But let's assume this is good, and it's actually we're pretty much where ATX specification allows it to be, and I wouldn't call that good, but it's within specs if I can trust this value. What if I put this back to the 500 milliseconds we used last time because we couldn't get anything else, and it was there about 20, and now it's, well, it didn't actually change a bit. Now it's very slow with 200 milliseconds, and same with 100 milliseconds. $50 milliseconds, when does it get faster? It's a bit faster, yes. 20 milliseconds. 10 milliseconds. It gets faster. 5, 2, now it's fast. 1. This isn't even ideal probe for this ripple measurement, but now, 2 microsecond setting, well, we can see it is between less than 40 to almost 50, and that would be good, but this to maybe 5 microsecond setting, well, it is under, it is within ATX specification, but yeah. So why did it now started working again, this scope? Well, this 200 millisecond setting didn't work. I'm not going to change anything here. I'm keeping this powered on for now. And let's turn this off. We can take the soft power off. And last measurement for that one as well. So yeah, I would have hoped a better 5-volt ripple, but it is within specs if you trust this measurement. So we're going to test another power supply, but I don't really have any strong 5-volt serviced power supply, 5-volt heavy serviced power supply ready nearby, so we'll just have to try with something else. But I suppose this is ready to be sent back. It works, and it is definitely better than before, and now it has good Japanese capacitors. I'd say this is good. Let's take this Nexus. This is almost certainly older. This is 300 watts, and this hasn't been serviced in any way, so I am actually taking a risk to turn this on. And we can see there's bad glue there, and we can also probably not, it doesn't appear on the camera very well, but this definitely isn't the same design. This is completely different design. And I'm just trying to see, what kind of capacitors do I see here, but I can see couple, but they are not bulging. And well, actually I think one of those capacitors might be bulging a little bit if you try to take close look. Yes, of course this is completely different design because the cooling fan is also very different. So turning this on is a risk. So, but I'm doing it anyways. I'm using, well, I better be sure what was the broken hard drive. We'll just take that one. This one. It spins but doesn't work otherwise. We'll just have to see what kind of ripple result we get with this one. Because I have absolutely no idea. Now, hard drive spins. And there's no smoke. The power supply fan, it started working. And this is still powered on with the settings last used. Let me put this here, perhaps you can see even better than last time. And let's measure wipe volt. Well, I don't know if these readings are to be trusted, but these are definitely much worse than with the other. We're almost double the ripple. Twice the ripple, and this is certainly isn't within ATX specification. Definitely not. Let's try 12 volt rail. Well, I don't know why those graphs jump all around. Do I have bad connection? Let me try on this side. I don't know what's going with the 12 volt rail because that graph jumps all over the place, so definitely that peak to peak reading isn't to be trusted. Let's take 5 volt again. And we're loading just one hard drive at the moment. There it is, about 80 millivolts. But what we can do is use multimeter to check those voltages. Minus 12 is more like minus 11. Plus 12 is, well, 11.9 almost, but that's actually good. And this also is 5.1 volts, so that's actually good as well. Power good signal, I'm sure of. Let's try here. Minus 5 is also too low, and the same plus 5. But at least we get about the correct voltages. That 12 volt I was more curious about because I can't. Let's try something else for the 12 volt setting. Why does it jump so much all over the place? Now with the 550 microsecond setting I get peak to peaks, but I can't. It's all over the place. What if I simply check with DC and measure the voltage instead of ripple? DC setting, there's nothing, it's just nice 12 volt. But let's go AC again. And we're jumping all over the place again. Actually, maybe I should just if the 12 volt ripple is actually over 300 millivolts, and it does seem it is, that's actually very, very bad. But then again, it is about twice what is allowed, and that 5 volt rail, well, it also appeared to be about twice what was allowed, so now I'm trying to measure 5 volt again, but I can't see anything. I'm on the 5 milliseconds. On this 500 millisecond setting, I get 5 volt ripple about above 100 millivolts. Let's go down. Those were too slow. Why is the 5 volt ripple now so much? This isn't centered properly, I think. Let's just remove this and try again. Now. It's like our 5 volt ripple went to much worse than it was originally. Just having about some minutes when running this old power supply, well, the 5 volt ripple is what it appears. It's twice what it was when I first turned this on, and it was already almost twice what was allowed in ATX specification. So with this unserviced Nexus power supply, and I'm sure this is FSP group power supply as well, well, we are way above ATX specification ripple, and this is very, very bad. And let's measure the 12 volt again. It's no longer jumps, but yeah, it is over twice what is allowed. So actually, I think my 50 millivolt per division isn't even enough for this. Let's try. Yeah, it wasn't. So we're over 400 millivolt ripple. At least it's stabilized at 12 volt trail. But the ripple is very, very bad. Very, very bad. I'm turning this off now. And you just saw ripple on unserviced power supply. 300 watts Nexus 5 volt heavy. And I'm sure this is by FSP group made also. So if you have Watson and whatever, well, this is what they are going to be. And this definitely aren't the worst there. Actually, this was actually, I think this FSP group power supplies were above average quality. Not high end, but above average. So they were not bad when they were released, and they are bad now. Absolutely they are. They have bad capacitors in them. They have glue that turns corrosive and conductive. And if the capacitors won't kill your system, well, eventually the glue will. After recapping with quality capacitors, yeah, you get nice power supply. So yeah, these are silent and nice power supplies otherwise, and I think they are worth to be serviced. And you absolutely must service these, absolutely. This power supply is ready to be sent back. And this was actually very little used power supply in the first place. The capacitors did look perfect. So I actually expect that these were good. But let's measure them. This capacitor is just fine. Nothing wrong with it. This was 25 volt 100 microfarad depot. Let's take the other kind of Jamicon 100 microfarad. Yes, it's good as well. Actually, let me. Perhaps it's faster if I just press them here. If I can. Yes, this 100 microfarad is good one. Here we have third type of 100 microfarad, 35 volts. This is actually, yeah, this is good. 47. Yes, it's good. No, there is 100 microfarad, another 35 volt capacitor, so let's... It was good. Actually best so far from the 100 microfarad capacitors. This is 2.2. It shows 2.7, but 10 microfarad, ESR 2 ohms. This is 10 microfarad, definitely yes. And 2.2 depot. No, I can't get proper reading. I need to use this. 3.5. This shows too high capacity. This is starting to, electrolyte is starting to react with the aluminium. And yeah, this is capacitor that's definitely starting to go bad. And I think that 2.7 micro was another one of those that's supposed to be 2.2. It's starting to get bad. Maybe these were under the heatsink there, but who knows. This is also 3.3 micros and it's supposed to be 2.2. It's again starting to go bad. 10 micro, this is good. This was the odd one, 16 microfarads. Let's actually connect it here. Because I didn't have this, so I need to, at the second, I replace this one with 10 microfarads and 4.7 connected in parallel. This is good. 17 microfarad, 70.5 actually. This is smaller, 47 micro. Can I even? Yes, that's good. 1 micro, but ESI is very bad. This is 1 micro, but I don't think 4 ohms ESI is good. So I think this is starting to go bad. This is exactly the same thing. Maybe the ESI is just high on these. Or perhaps this really is going bad. This is good. 2.2. This is 1 micro, but 5.5 ohms. Depot. This is different brand. It was Semicon other 1 micros. Are they supposed to be that high? We can actually measure some new one. Because so far it looks this is 1 micro as well. All the 1 micro capacitors have so high ESR. Be absolutely sure. No, it's the 4 ohms. 1 micro. It's exactly the same thing on all 1 micro capacitors. This is 2.2, very small one. Let's just use this. Yeah, this is also very high ESR, almost 6 ohms. Certainly the other 2.2s weren't this high of ESR, but this is smaller sized. But I don't think. Did we actually have so many small capacitors that were starting to go bad? Let's just quickly measure one completely new 1 microfarad capacitor and do comparison. Well, actually it is very high ESR, at least this one. I think I should have another. So the ESR, it wasn't an issue. It was just the high ESR, these 1 micros. What about this other? This is only 3 ohms. This I used Rubicons. These are physical sizes quite big actually. So let's measure one of these. 1.8, these are the lowest ESR, 1 micros. And yeah, so there definitely is different. But let's continue. Was that the last of the small ones? Yes. So I'm sure the 1 microfarad were all good, but those 2.2s, was there something else? Well, maybe a couple of them are starting to go bad, but nothing too serious yet. Yeah, this is low ESR, and I think all the smoothing capacitors should be low ESR. This was for the 5-volt standby rail, and we replaced it with another 170. There wasn't space to use those bigger ones. This I'm most interesting because this handles the 12-volt rail alone. And on the 250 watt power supply I did on the ASUS P3BF build, well, it showed ESR that wasn't low, but it wasn't very high either. But I couldn't tell if it was supposed to be low ESR capacitor or not. But I think this smoothing capacitor should be. So, is this or not? Let's see what it reports. Yeah, this is low ESR. This is perhaps a bit low, this microfarad reading, but it is within specification. It is about the minus 20% almost. And definitely low ESR. So the 2200 microfarad 16 watt capacitor on that 250 watt power supply I did last time on the P3BF build, well, that capacitor was starting to go bad, but this is good actually. And both of these are so good. Let's continue. This was on the 5-volt rail. And why it was just 1000, I replaced this with 3300. Definitely low ESR. And definitely this is okay. And the low ESR seems to be 0.6 ohms so far on these, used on this power supply. The 3 remaining are the same. 2 for the 3.3 volt rail and 1 for the 5-volt rail. This is good. And pretty much ESR is pretty much like we already seen. Actually, this shows quite high ESR. Is it? Yes, it was just bad connection. It's good. It's just as the previous one. This is the best so far. Definitely still good. And these big ones, I'm sure these are good. This was very little used power supply anyways. 0.4 ohms, 750 micros, and this was supposed to be 820 micros. This is perhaps bit low, but I'm sure it is within specs. Let's take the other one. And we now have much better AC smoothing capacitors. This is exactly the same. 730 micros and 0.4 ohms about. So these are good, although a bit lower reading than supposed to be, but nothing serious. So really, I think that power supply was safe to be used, but I'm sure we improved the ripple, and of course that those capacitors would have gone bad anyways soon. They are 20 years old. Maybe we could do something, just Panasonic FR series, 3300 micros, 6.3 volts. Yeah, 0.37 ohms. And that's pretty much what the FR series was when I fixed the ASUS P3BF motherboard. I used the 1500 FR series Panasonics. This has the same ESR. Now let's take this 10 volt Rubicons PX series. These have a bit higher ESR. but pretty much the same that were originally used on there. So yeah, and there wasn't any other 10 volt capacitor 10mm in diameter, so I didn't have any choice, except I could have used these taller ones, 16 volt ones as well. Yeah, microfarad reading is a bit low, but just within the -20% tolerance. And ESR, it gets lower. It's pretty much the same as those FR series Panasonic. This is now ready to be sent back, and thank you for watching, and goodbye.